Picking up where we left off, we're going to do two problems. Our first one: if a gas in a balloon has a temperature of 273 Kelvin, so we know this is a temperature, and a volume of 22.4 liters, so we've got a temperature and a volume, right? 273 and 22.4 liters. What will the temperature be? So that's our unknown. What is our temperature to if the volume is increased to 31.0 liters? Now, from these numbers, we can see all these numbers have 3 sig figs, and so we know our final answer has to be rounded to 3 sig figs. And also, our units of measurement for volume are the same. They're both in liters, and so we're good there. And then remember what I said before, the temperature has to be in Kelvin no matter what, and it is in Kelvin, so we're safe with that. So we can move forward. Remember the requirements of the assignments are you write down the equation first, then you plug in your numbers. So I know where my T1, V1, and V2 are based off of me writing them down over here on the left of my givens. So I can type in those. Now, students often have a hard time mathematically with this because what they'll do is they'll take this 31 over here on the right and they will divide it over to the left-hand side. Well, that would leave you an answer of 1 over T2. So that doesn't work. What we need to do is we need to cross multiply, right? 273 times 31 and 22.4 times T2. Now, you don't have to show this step. I'm just showing you to make sure that you're going to do your algebra correctly. Now that we have this, now we're going to divide both sides by 22.4 to get our answer for T2. And as I said, I rounded it to 3 sig figs. I made sure I said T2 equals. I make sure my number is in sig figs and I have units on it. So we are ready to go. Our second one: what will be the volume of a gas sample at 82 degrees Celsius? Well, we have gas at 82 and we're looking for the volume when it's at that temperature. Now it says if its volume at 0 is 8.57. So when the temperature is 0, the volume is 8.57. Remember though, the temperature has to be in Kelvin. It's not. It's in degrees Celsius. Even though they match up in degrees Celsius and neither of them are negative, it mathematically will not give you the right answer unless you're in Kelvin. So I need to write down my equation for converting. I need to show my work, right? My T1 was 85, and so 85 plus 273 is 358. The other was T2 is 273. Now I have the numbers I need. I've got my two temperatures in Kelvin and this volume over here in liters. And so because my volume is in liters, when I solve for volume 1, it will also be in the unit of liters. Write down that equation. I've got my numbers, right? I know that I'm looking for V1. My T1 is over here at 358. My T2 is over here at 273. And then, of course, we know that the problem gave us the 8.57. Now, 0.00 gives us a little bit of an issue with sig figs. It's like all significant figures are based off of non-zero numbers, and that doesn't have any non-zero numbers. So just kind of ignore it and look at the other two. This is 2 sig figs, and this is 3 sig figs. So we know our final answer has to be rounded to 2 significant figures. Okay, here we go. So we are going to cross multiply, right? 358 times 8.57 and cross multiply again. Now, that 358 times 8.57 gave me this huge long number in the calculator. Because I know I'm going to round to 2 sig figs, I really could have cut this off here and just wrote down the 3068 if I was doing it separately. And remember, you don't have to even show this part of your work. You just have to plug in the numbers, equation, plug in numbers, and then answer with units. But anyways, so I divide both sides by 273 and I get my answer. And oh, look at that. I messed up. I did not go to 2 sig figs. So that's really not the answer. It's actually 380 Kelvin because I had too many sig figs there. Okay, so you've got 4 problems on these. Make sure you turn it in, model your work exactly like I've shown you in this video, and you should be good.